Okay. So if you take a look, here's what we're doing today. Like I said, everything we've done over the last 3 days has been, here's the equation. Identify A, B, C, and D. And then find the period and phase shift and all that stuff and come up with the graph. What we are now going to do for the last couple of days is, given the graph, we want to identify those same important features, but then be able to write the equation that matches that. Okay? So there's a little bit of reverse that we're doing here. Quick heads up on this, just notation-wise, so that you're understanding what's going on. It depends on the book. It depends on mainly the book. So we've been talking about A, B, C, and D. A is amplitude. B deals with the period. That's the same regardless almost in any book. But some books then use C and D, like we have been with horizontal and vertical shift. Some books use, like we've talked previously about H and K. H being your horizontal shift, K being your vertical shift. The reason I bring that up is this worksheet is not from your book. When they're talking about K here, that's really D, what we've been doing. That's the vertical shift. When they talk about H down here, that's really C. That's your horizontal shift. Okay? So on this worksheet, just a quick clarification. K is really D. H is really C. Okay? It's the same thing, it's just coming from a different place. H horizontal. C horizontal. Yeah. So just like I said, we've been using A, B, C, and D because that's what the book uses. Okay? We've been using the term phase shift because that's what the book uses. It's really just horizontal shift. All right, let's take a look here. We're going to do the first two together, and then the other four will be your assignment for tonight. So if we take a look, we still need to identify those four important features, A, B, C, and D. I'm going to start on the graph the same way we've always started. Where's the midline? Where is it? 3. It's halfway between your max and your min. It's right down the middle. So if you take a look, it is right here. Oops, I'm going to change colors here so you can see a little bit better. Halfway between your max and your min. Okay. By identifying the midline, what did we just find? D. D is 3. I found one of the 4 values I need. It's just wherever the midline is, that's your vertical shift. That's D. Now we can find the second one very quickly. What's A? 4. Yeah. From your midline, you're going up 4 to get to 7. You're going down 4 to get to -1. Amplitude is 4. There's 2 out of the 4 values. We got A and D. Now we need to do B and C. Okay? What's the question, Preston? How did I get 3? Maximum is at 7. Minimum is down here at -1. So we've got a total distance of 8. So halfway would be down 4 or up 4. Just halfway between the top and the bottom. Total distance from top to bottom is 8. So half that distance would be 4 down or 4 up. Okay. All right. So we've got those 2. Now we need to work on B and C. Normally, what does B always help me to find? Period. We're working backwards now, though. So we're going to use the graph and figure out what the period is, and use it to find B. So as you take a look, remember what a period is. It's just how long does it take to complete a full wave. So you can pick any 2 points on here and figure out how long it takes to get from the whole wave. What I'm going to pick, I'm going to go, for no specific reason to be honest, I'm going to pick a maximum to a maximum. We go from here all the way through to the next one. We've completed 1 full wave. How long does it take? If you notice, this one's at 3, and the next one's at 9. It takes 6 radians to get all the way through a full wave. Okay. Now, how does that help us find B? The period, remember, is 2 pi over B. And we know that the period, based on what we just said, is 6. We don't need to find the period, we know it. And now we solve for B. What do we get? Multiply both sides by B to clear the fraction, and then divide by 6. Ultimately, b and 6 switch spots. So you get 2 pi over 6, which means b is pi over 3. All you're doing is solving that. If you multiply both sides by b, you'd get 2 pi equal to 6b, and then divide it by 6. That, regardless of whether we're finding a sine equation or a cosine equation, those three things do not change regardless of whether it's sine or cosine. What does change is your phase shift, the horizontal shift. Because what's the difference between sine and cosine when we graph, when we do our phase shift, our starting point? Cosine starts with a maximum, sine starts with a midline. So the phase shift is going to be different when we come up with sine versus cosine. I'm going to start with cosine. And the reason is because I kind of highlighted a maximum already. Okay? Now, what I want to give you a quick heads up, because this is one of the main things for today, is there is not one right answer to these problems. Okay? It all depends on, in this case, I'm going to look at cosine, and I'm going to go with a maximum. I'm going to use this maximum, the first one right here. Which means, by the way, what's the phase shift? If that's the maximum I'm using, how far did it get shifted? Yeah, it's 3 to the right. Normally it's on the y-axis, it got shifted 3. I say there's multiple answers because I don't have to use that maximum. I could use this one if I want, and then my phase shift would be 9. I could use this one in the negative direction, and then my phase shift would be negative 3. Okay? So there's a lot of different equations you could come up with. It completely depends on which point you use. And I'll come back to another one at the end here in a second. So in this case, I told you I'm going to use 3. I'm going to use that first maximum. So phase shift is the opposite of c divided by b, which we just found is pi over 3. So I'm going to put that in. That equals our phase shift, which we said was 3. Like I said, if you used a different maximum, then it might not be 3. It might be negative 3. It might be 9. It all depends on which maximum you used. And now, once again, just like up above, we're going to solve for c. In order to get this pi over 3 out of the denominator, we're going to multiply both sides by that. So times pi over 3. When I do it on the left-hand side, this will cancel out. What does 3 times pi over 3 equal? Okay. Yeah, you end up with 3 pi over 3. The 3's cancel. You get pi, which means the c value for this cosine wave is negative pi. Here? Is that what you're talking about? No, I just multiplied by the denominator to clear the fraction. That's all. I just multiplied both sides by pi over 3 to clear that, to get the denominator out of there. So now we have a, b, c, and d. I can write my cosine equation. All we have to do is put it all together. So if we do that, we have y equals, a value we said was 4, so 4 times the cosine. B value you said was pi over 3. I'm going to move this up a little bit. And you can use x, you can use theta, whatever you want. I'm going to use x because that's what we've used most of the time. So pi over 3x, we just said c was negative pi, so minus pi. And we said the vertical shift, the d value was 3, I believe, if I remember right. So we throw a plus 3 at the end. Now, let's go back and find if this was, stay on this problem, we're not quite done. Only because I want to also write this as if this was a sine wave. Okay. Before I do that, real quickly, by the way, I didn't want to put it out there right at the beginning, but I said we use this maximum for our cosine. And you can use any maximum, it's fine. That's where normally a cosine wave starts. Starts at a maximum and then goes down. What if I would have used this minimum? how would that have changed things? Then it would have made a negative. So it actually would have probably been easier to do it that way, because if this is what I'm using, what's my horizontal shift? Nothing. Okay? I didn't want to do it that way to begin with, because I didn't want you confused immediately of, I wanted you to finish this and see how most of the problems are going to go. But had I used a minimum for my cosine, that would have just changed the a value to be -4 instead of +4. That's that reflection. Okay, so just a heads up, that's another equation you could have had. All right, let's say we're going to do sine. Normally, sine starts at a midline and goes up to a maximum, which means I'm going to choose this point right here. Let's say that's my midline that then goes up to a maximum. And again, there's multiple points we could choose. If that's the point I'm choosing, what's the phase shift? What's the horizontal shift on that one? 1.5. Yeah. Each of these dots is going by 1, and we're halfway between 1 and 2. So 1.5 would be your phase shift on this one. Okay. So let me go down here just so I have room to work. Again, if we go back to phase shift, remember that's the opposite of C over our B value, which is still pi/3. That doesn't change. But now, we said when it's a sine function, we're shifting the midline, not shifting the maximum. So it changes C. We said it's 1.5, only because I think it'll make more sense. I'm going to write that as 3/2. So your phase shift is 1.5 for sine. And now you solve it the same way you solved the other one. Multiply both sides by pi/3 so that we clear the fraction. So the opposite of C equals what? Yeah. You get 3 pi/6. This will reduce. You get pi/2. And therefore, C for the sine wave is negative pi/2. The C value, the shift for our sine wave, again, is different because we're shifting a midline point and not shifting a maximum. And now we write the equation. Everything else stays the same. We don't have to go back and worry about anything else. Y equals 4 times the sine of pi/3x. But instead of minus pi, we now have minus pi/2. Oops. Let me stop. Let me pause. How are we doing in general? You may not have it after one example. May not have it down perfect yet. But in general, making some sense? Getting there? That's why we're going to do another one. Okay. All right. Let's take a look at problem 2. Go to the next page. Let's do one more together. All right, let's do the stuff that we can just take straight from the graph first. Where's the midline? -2. Halfway between your maximum and your minimum. Maximum is at -0.5. Minimum is at -3.5. So that's a distance of 3. So if you go down at 1.5 and up 1.5, your midline is right here. Which means if the midline is at -2, that is also your vertical shift. What's the amplitude then off of that? Off. Yeah, 1.5. Okay. Amplitude would be 1.5. And I don't care if you write it as 3/2 or 1.5, either one is fine. One quick heads up, by the way. Make sure that as you look at these, make sure you look to see what each dot is going by on the x and the y axis. They're not always 1. Okay? In this case it is. These are going by 1s, but they're not always 1. So make sure you look to see what the scale is. Okay? Next up, let's find the b value by identifying the period. And again, remember the period is just one. How long does it take to complete one full wave? So in this case, I'm going to use maximum values. How long does it take to complete one full wave? 8. From -2 to +6. Maximum to maximum is a total of 8. So 2 pi over b equals 8. That's the period. Which means b equals what? Yeah. You end up with pi over 4. Multiply by b, divide by 8. That'll get b by itself. You get 2 pi over 8 reduced as pi over 4. All right. There's 3 out of the 4. There's the 3 that you're going to have in both equations. Now we got to look for the horizontal shift. Maximum versus midline. Let's start with maximum again. If we're doing a cosine wave, we shift the maximum. That's our phase shift. I could use -2. I could use +6. Okay. I could use a minimum if I wanted to, but then switch the amplitude to be negative. Okay. So there's a lot of options as you work your way through it. And it doesn't matter. All of them are right. Okay? So whatever one you want to pick, -2 versus +6 versus -2 with a negative amplitude, any of those will work. Okay? Which one do you want to use? I'll let you decide. -2. Sounds good. Let's do it. Okay? So, in order to find the C value, remember your phase shift is the opposite of C divided by B, which in this problem we've already identified as pi over 4. And for our phase shift then, we said it's going to be -2. We're going to use the -2 as our shifting the maximum. Could also equal +6. Could also equal +2 with a negative amplitude. And now when we solve, clear the denominator. Multiply both sides by pi over 4 to clear that denominator. Which means that goes away. And when you do the math, what does C equal? Pi over 2. Yep. You get a -2 pi over 4, which reduces to pi over 2, and then you got to get rid of the negative to the C. So C in this case is pi over 2. That's the C value that goes with your cosine. Okay. That's the C value that goes with cosine, because we shifted the maximum. And so once again, now we just write the equation off of that. Y equals 1.5 times the cosine of pi over 4x plus pi over 2, our C value. And then we said, what did we say D was? +2? -2. -2. Thank you. -2 at the end. What's going to be the only difference when we go to the sine graph or the sine equation? Okay, yeah, the plus pi over 2, the phase shift will be a little bit different because we're not shifting a maximum with sine, we're shifting a midline. So let's go back to this one and let's identify if this was a sine wave. Again, you got a lot of options. I could choose this midline point right here that then goes to a maximum. That fits with our parent function. I could choose this one, which then goes to a maximum, still fits. Or I could choose this one. But then what would happen? But then because we're not going to a maximum, we're going down to a minimum. If I use that one, then A would be negative. Okay? Then that makes the amplitude negative because we're going down instead of up. Okay? Again, it doesn't really matter which one you pick. Take your phase shift, set it equal to whichever one you pick, and then solve for C from there. Okay? I think in this case, since we use -2, I'm going to use -4 just to kind of be consistent. Okay? But there is no rhyme or reason. It doesn't matter whatsoever. Okay? So in this case, opposite of C over B, which again, pi over 4, that doesn't change, equal to, I'm going to use -4 as my phase shift. Okay? I'm going to say we took the sine wave and moved it 4 to the left. And once again, solve for C. Multiply both sides to clear the fraction. If I multiply by pi over 4, that cancels. And ultimately, what will C be then? Yeah, you get negative pi here, and then you got to change the sign. C is pi, if that's the phase shift that you used. Okay. So once again, the only difference between these equations is that phase shift. Y equals 1.5 times the sine, pi over 4 times x. Now we have plus pi instead of plus pi over 2. And then we still have the minus 2 at the end. Everything else is the same. Was I right, by the way, that this generally is easier than what we've been working on? Okay. No, I was not. So like I said, we just did 1 and 2. What I would like you to do for the assignment are the other 4. You got 4 other ones in here. And right now you've got about 10 minutes left where you can get started on it. There were some people today in my first hour class that in the 10 minutes, they actually finished the other 4. Okay? Quite a few other people finished shortly after that. So these 4 problems shouldn't take you more than maybe 15, 20 minutes total, something like that. It should be a fairly short assignment. Okay? Go ahead and go to work. I will come around and check on you and see where you're at with previous stuff, with this stuff, and we'll go from there.